The indefinite integral from pi over 2 to pi of sine 2x over 2 times sine of x. Well, it's a bummer that this is a sine of 2x and it's a sine of x. These two trig functions have different arguments. Often what you want to do in those cases is find some way to make the arguments of your trig functions the same. I recall that there is a trig identity since the sine of 2x is sine of x times cosine of x plus sine of x times cosine of x. Actually, what I have memorized is sine of a plus b is sine of a times cosine of b plus sine of b times cosine of a. But since this is x plus x in the form 2x, a and b are both x, in the language I just used, I can do that. All right, comma. Now, centering this, I can replace the integrand of this integral with sine x cosine of x. All right, simply make that substitution, and down there to sine of x. And as you see, the integrand has been vastly simplified. The integral from pi over 2 to pi of simply cosine. Cosine of x. Very nice. All right. So now, by the fundamental theorem of calculus, I should take every opportunity I can to say that I'm using the fundamental theorem of calculus. This definite integral, which is a limit of Riemann sums, is an antiderivative of cosine, I believe negative sine of x is derivative cosine. Nope, I got it wrong. It's positive sine. The derivative of positive sine is cosine. Pi over 2 to pi. And that is simply sine of pi, which is 0, minus sine of pi over 2, which is 1. So overall, I get a negative 1 by the fundamental theorem of calculus, going from there to there. Again, I was evaluating this limit of Riemann sums, which you can call a definite integral. That's just a short nickname. This limit of Riemann sums can be evaluated by antidifferentiation. That's what the fundamental theorem of calculus is.